Okay, guys, I'm gonna need you to finish your last two relationships with dealing with angles with the circle. Our last two boxes in our green notes. Okay, so on your notes, you will need to fill in these two parts about angles in a circle. We're looking at interior angles. It's a different relationship than inscribed angles or central angles. When you have an interior angle, first thing I need you to, let me put my pen, record is that the vertex is not at the center. Okay, whenever we have an interior angle, the vertex is not at the center, because if it was at the center, it would be a central angle. And if it was on the circle, it would be an inscribed angle. So we're talking about just when the vertex is not at the center, but inside in the interior of the circle. So we have an interior angle. It will end up being 1/2 the sum. That means we're going to end up adding the measure of the two intercepted arcs. Okay, so angle A is in the interior. I want you to hopefully recognize that angle A, and let's say if I had an angle 1, those two angles would be vertical angles, so they would be congruent. But what you need to recognize to find the measure of those angles are the intercepted arcs, the arcs that are in the interior of those angles. So if I look at angle A, the intercepted arc with angle A is right here, the x. Okay, the x is representing the measure of that arc. And the arc that goes with angle 1 is your y. So this formula here is trying to show you that angle A would be 1/2 the measure of adding arc x and arc y together. Okay, so the relationship we're hoping that you remember and recognize is that when you're dealing with an interior angle, okay, the interior angle, and I'm going to abbreviate, is always equal to 1/2 the sum of the intercepted arcs. Okay, and I'm going to show an example of that with our second circle here. I'm hoping you see that M is the intersection of these two chords. Okay, so we do have an interior angles. Let's say we have 1 and 2. We're going to add 1 and 2. And 1 and 2 are vertical, so we know they're congruent. But we need to identify the intercepted arcs for each one of those. So the intercepted arc for angle 1 is the JL, or the LJ. And the intercepted arc for angle 2 is the NK. I didn't curve, sorry about that. So to find the measure of angle 1, okay, the measure of angle 1, it would equal 1/2 of arc JL plus arc NK. So we're adding the two. Okay, and that you could put that with your example, but make sure you understand and you identify that relationship. And on our last little box, when dealing with exterior angles, the exterior angle, your vertex will be outside the circle. Okay, you got to be outside the circle. So if you look here, we have two secants, and when they intersect and when they meet, the vertex would be outside the circle. Same as if you had a tangent secant. Okay. Now, to help you see your intercepted arcs, because you're going to still use that same relationship as with interior angles, because now the exterior angle will be 1/2 the difference of the two intercepted arcs. Okay. Now, so since we're doing difference, we're dealing with subtraction. So what we're going to do is we're going to add some points of intersections here. Okay. And if I wanted to go ahead and label, we could say A, B, C, D. All right. And let's go ahead and put E. C, D, E. There we go. Alright, so I need to identify the intercepted arcs for our exterior angle. There's two of them because we want the arcs in the interior. Well, the major or the larger arc, not necessarily major, but the larger arc would be arc X because it's in the interior or inside or in between the angle. We also have the arc Y here. So this rule, what it's trying to show you is that if you take the measure of the arc minus X and minus the measure of arc Y and take half of that, that would equal to the angle. It is basically going to give you your angle. So another way I can look at this is saying that angle E would be equal to 1/2 BC, take the larger arc, and that's the one furthest from the angle, minus AD. And when you subtract the two, take half of it, that would equal to its measure. Now, I can have an exterior angle formed with a tangent, and of the two lines that we have here, the tangent is the one that has only one point of intersection. So there is the one point of intersection, sorry about that. And then a secant. The secant will have 2 points of intersection. Okay? Same thing, we're still going to have an exterior angle. And to form that exterior angle, or to find the measure of that exterior angle, we're going to look at the intercepted arc. So we have the arc here with X and the arc with Y. And so the same formula will hold true. The exterior angle is going to equal 1/2 the difference X, which is X minus Y, of those two arcs. Now this is the last relationship you need to know to help you complete your notes. There is a video explanation with some of the problems. I probably kind of went over the odds. You are going to complete our problems. And if you have questions over the homework, which is already posted on Edmodo, you should be posting those on Edmodo to make sure you understand everything that's going to be on your quiz over the homework on Tuesday. All right. Hopefully this helps you. Use any other additional links that I have on Edmodo. And if you are still needing assistance, please come to tutorials. Thank you. Bye.